We have uncovered a remarkable planet. A world of extreme weather, alien landscapes, and bizarre phenomena. It's the most complex system we know of in the universe. That planet is Earth. And we're only beginning to unlock its secrets. It seems like a most familiar sight, but in fact, it's one of the strangest phenomena in the universe, and humans couldn't live without it.
The water that is in our bodies right now has been around for millions of years, and all of us probably have water that passed through Albert Einstein, George Washington.
It's called rain. Created by powerful but little-known forces, it teems with mystery, and even sometimes with life. Rain, decoded on Secrets of the Earth. Even from space, it's clear that Earth is a special planet. It's unique in this solar system because it has massive oceans. And it rains water from the sky.
When you look down at the Earth from space, the two things that jump out at you are the white, the clouds, and the blue, the oceans.
Canada's Vancouver Island, the wettest place in North America. Here, it can average an astonishing 256 inches of rain a year.
The oceans, the clouds, and even the water on the moss around me here, it's all part of the same water cycle, the cycle that sustains life on the planet. This cycle includes everything, from my breath adding moisture to the air, to the water hanging on this moss, to a river like this, flowing towards the ocean. Or this.
Even the world's driest deserts, like Death Valley, are shaped by rain.
Here in Death Valley, even though it's an extremely dry place, everywhere we look, we see evidence of the work of water. That it sculpts the landscape, it creates these fantastic shapes that we see here, and this arroyo that's located behind me, that's deeply carved, deeply incised into this hillside, is caused by torrential rains that flood down the slope, carve into the landscape, and move those sediments downstream.
Rain may seem simple, but few people on the planet understand how it actually works. How it relies on visitors from outer space and strange creatures from Earth to make it fall from the sky. The secret life of rain begins with the basic fact that across most of the Earth, rain starts out not as a liquid, but as a solid.
Here in the rainforest on Vancouver Island, it's raining on me right now. But these rain droplets didn't actually start as rain. They started in the clouds as snow, which is a combination of ice, air, and little droplets of water. Most rain on the planet actually starts as snow.
High in Earth's atmosphere, it's far below 32 degrees. And as every child on Earth is taught, water freezes at 32 degrees. Except that it doesn't.
It wants to freeze because it's below the freezing point, but it can't. It needs an impurity around which ice crystals can form, and then a solid can take place.
And this planet's atmosphere is full of tiny impurities that play this vital role.
The particulates that we find in the atmosphere come from many different places. From sea spray, from the ocean, from forest fires and the smoke that they produce. And even here in Death Valley, in a sandstorm, it's gonna pick this sand up, toss it into the air, and carry it into the clouds.
And some rain-making particles actually zoom in from outer space. Every day, 6,000 pounds of tiny micrometeorites crash into Earth's atmosphere.
It's hard to believe, but it's estimated that the Earth may get heavier by perhaps 10,000 tons or so every year because it's sweeping through this dust cloud of tiny micrometeorites.
They're very tiny. A micrometeorite is less than the width of a piece of human hair. And what that means is that there's not that much friction as they're falling, so they don't burn up in the atmosphere like a big meteorite would.
This micrometeorite, once part of the tail of an ancient comet, hits the atmosphere. It slows down and eventually drifts into a cloud full of microdroplets. They're below freezing, but they can't crystallize without coming into contact with an impurity like this tiny space invader.
They encounter one of these particles in the atmosphere and crystallize around a single particle.
This happens billions of times a day. And the proof is everywhere on Earth.
You can actually look for micrometeorites yourself. All you want to do is collect some rainwater. You get yourself a really strong magnet. You take your magnet and just swish it around in the water for a couple minutes to make sure you pick up everything that's in there. If you look through them under a microscope, anything that's really spherical, there's a good chance that it's actually a micrometeorite.
Now that a water droplet has turned into an ice crystal around the micrometeorite, the crystal itself creates an even larger solid surface for other tiny droplets to freeze onto as well.
But turns out ice is the best template for ice. So once you initiate freezing, you can very readily form many, many crystals from that template.
The tiny crystal grows into a snowflake, heavy enough to begin to fall. But its journey is far from over.
The closer it gets to the surface, the warmer the temperatures, and as it passes through that warm air works to add energy to that ice crystal.
The snow begins to melt and turns into rain.
Here in Vancouver, it finally reaches the ground.
So on a rainy day like today, if you reach out to catch a raindrop, you might actually catch a little micrometeorite.
But take a close look at that raindrop. There might be something else inside. Instead of being formed by a tiny speck of sand or micrometeorite, it might have been formed by a living being. If so, that would hardly be the strangest kind of rain to fall on the planet Earth. For years, scientists on Earth believed that all rain was caused by water condensing on solid particles in the air. But it turns out that some rain is actually caused by living creatures trapped in the sky and desperate to get back to solid ground.
We've known for a long time that many microbes use the atmosphere to get around. Within a cubic meter of a cloud, there may be as many as 100,000 microbes.
Every day across the planet, warm air on the surface rises into the atmosphere, pulling 2 million tons of bacteria along with it. One of these bacterial species is a remarkable creature known as Pseudomonas syringae that lives on plants, including those that mankind grows for food.
On a typical plant leaf like this, a cubic centimeter could contain 100,000 individual microbial organisms.
farmers hate Pseudomonas syringae because it has a bizarre ability to create frost on crops at temperatures where water wouldn't usually solidify. How does it do this? Incredibly, it has evolved a protein that forces water to take on the same solid shape as an ice crystal. Cold water then locks onto the crystal, forming additional ice.
Here in southern Louisiana, we don't see freezing very often, but when it does happen, it can decimate crops. So for example, this field of sugarcane can all be wiped out in less than an hour. Pseudomonas syringae and other ice nucleators which are present on crop surfaces are responsible for most of the damage which occurs during freezing. We can demonstrate what Pseudomonas syringae might do right here in the laboratory. Here we have some liquid water that's been cooled down to about 20 degrees Fahrenheit. You'll note that it isn't frozen. I'm going to add a sample of the Pseudomonas syringae culture. And it freezes instantaneously.
This secret talent for turning water into ice isn't just used for causing frost on plants. As syringae floats into a cloud and comes into contact with a cold microdroplet, it forces that droplet to crystallize into ice. The droplet quickly grows into a snowflake, melts into rain, and falls back to Earth. This microscopic creature is carried back home, riding in the raindrop it created.
They will incite precipitation and make their way back to surface environments that they call home.
But syringae is hardly the strangest secret of rain. Even stranger is the fact that every rainstorm and every human body, including yours, contains ancient water molecules that once existed in every dinosaur and every other person who once walked the earth. Since humans are largely made of water, the cycle of rain even includes the human body. Up to 60% of the human body is water. The human brain is 70% water. Human lungs are nearly 90% water. And that water has been endlessly recycled. From the days it first rained down on early Earth in frozen comets, to the age of dinosaurs, to the rise of early man, and all throughout recorded history.
The water that is in our bodies right now has been around for millions of years. And all of us right now probably have water that passed through Albert Einstein, George Washington.
For it to rain on Earth, water droplets in the sky need to freeze around something solid, like a micrometeorite or a microbe. But how does the water get into the sky in the first place? It's a hot afternoon in a North American suburb. From the surfaces of the houses, lawns, roads, and buildings, liquid water is warming, evaporating, and entering the air as water vapor. Near the surface, water molecules in this typical puddle absorb enough heat to make the leap, the sudden transformation from liquid to gas. In a split second, they separate from their fellow water molecules in the puddle and rise into the air.
As air parcels become warmer than the surrounding air mass, they become unstable. They're less dense. They're going to rise like a helium balloon up into the atmosphere and carry that moisture with them.
Across the planet, 92 quadrillion gallons of water rise up from the oceans and land every year.
The average residence time for a water vapor molecule in the atmosphere is about 10 days. So over the course of 10 days, this average water molecule can travel thousands of kilometers.
At any given moment, there are 25 million billion pounds of water in the sky. If it all fell out at once, it would cover the whole planet, both oceans and land, in 1 inch of water. As a water molecule rises, it also cools at a constant rate of 5.5 degrees for every 1,000 feet. As the cooling air gets denser, the water molecule starts slowing down. Suddenly, it hits a critical moment. As it bumps into another molecule, they latch together and condense back into a liquid. If enough of them do the same, the whole mass becomes visible to the humans on the ground. A cloud is forming.
We begin to be able to see those water droplets coming together. So there's enough condensation so that it reflects the light and we can see it as a cloud.
In the solar system, clouds themselves are not that unusual. On Venus, a perpetual cloud of deadly sulfuric acid powerfully reflects sunlight back into space.
That's why it shines so brightly, and that's probably why Venus was named after the goddess of beauty and love, because it shines so brightly, but it's due to sulfuric acid.
The clouds of Mars are wisps of carbon dioxide. Jupiter's are thick with ammonia. In Earth's clouds, microdroplets of water are far too small and light to fall to the ground. Millions will have to lock together into an ice crystal to begin their journey back to the Earth's surface. And to do that, they need to form around something solid. This is where particles from billowing sandstorms, forest fires, erupting volcanoes, micrometeorites, and even microscopic creatures come into play. But sometimes on planet Earth, even stranger things fall from the sky. The watery rain of Earth is unique to this blue planet. But the universe is full of strange rain.
On Venus, it rains sulfuric acid. We think on Titan, a moon of Saturn, it rains some kind of ethane, which is very similar to methane.
But Earth also has its share of strange and bizarre forms of rain. Throughout history, people have reported frogs, lizards, fish, and eels pouring from the skies.
Believe it or not, stories about it's raining frogs and it's raining fish are actually true.
There were 600 published reports in the 20th century, including widely reported incidents in Australia in 1906 and St. Petersburg, Florida in 1952, when fish poured from the skies. Buckinghamshire, England in 1969, when frogs rained down. And Connecticut in 2003, when tiny gelatinous frogs' eggs pelted the town of Berlin. The secret culprit of these strange rains is a surprisingly common phenomenon: the waterspout. Essentially a tornado over water, a waterspout can spin at up to 200 miles an hour. Anything within several feet of the surface can be pulled up into the vortex.
It will suck into the funnel many of the sea life, and it will rain down on people.
Even when the waterspout stops spinning, the life within can travel up to 100 miles, buffeted up and down by powerful updrafts. Eventually, though, the winds calm down, and the Earth's strangest rain pours onto the land. But rain itself, the watery kind, has held onto its secrets for millennia. Only now are humans discovering how water really makes the astounding leap from solid to liquid to gas, a feat that remains unique to Earth. How rain is dependent not just on temperature and pressure, but on volcanoes and forest fires and dust storms, on invaders from space, and even invisible forms of life. And most of all, how rain has turned this third planet from the sun into the most watery place we know.